Alright, as promised, we're going to start talking about 8.2, that's law of cosines. We use this in side triangles and side angle side triangles. Remember from the last video that side, that means you have all sides. This means that we're going to be solving for the interior angles. And remember that side angle side means that you have two sides and then the angle between them. I always like to think of this as having all three beginning letters of the alphabet. So I have alpha, which is A in Greek, B, and C. So A, B, C. Okay, or I could have had beta, A, C. So I have A, beta, C, A, B, C. All right, so we're going to be looking at that a little more closely when we get into solving problems. Really quick, law of cosines has to be one of my favorite sections to talk about because it's not that hard. It's mostly just plug and chug. We don't run into ambiguous cases, and it has so many real-world examples. We'll be getting into that a little bit later too. I'm going to nerd out pretty hard on you guys. Alright, so no time like the present. Let's get to it. So what is the law of cosines? Well, the law of cosines is simply this. You can pick any one of these three to work with. It depends on how you label your triangle and also what you're trying to find. Okay, so typically if you're trying to find interior angle alpha, you're going to want to use this one. Or if you're trying to find side length A, you're going to use this one. Same thing goes for all of these guys. Okay, so it's just side length squared equals B squared plus C squared minus 2, don't forget that 2, that's really important, 2 times B times C times cosine of alpha. Same flows for these guys. Okay, so what we're going to do is we're just going to jump in, get our feet wet, start with an example. Okay, so say that I have been contracted by somebody to drill a tunnel through a mountain, right? So they want me to drill a train tunnel through a mountain, like so. And I need to find out how the distance the tunnel is going to be, right? So in surveying, we run into this problem a lot where we can't measure something directly through. Okay, so if we were to look at a mountain from an aerial view, right? So the mountain would look something like this, maybe. Okay. If I get a tunnel through here or through here, the lengths are going to be very different. Okay, so it definitely matters. I have to pick points on where I want my tunnel to go. So let's say I want my tunnel to go through here. Okay, and also notice that my mountain is nothing resembling a circle, right? So I couldn't just measure around and then find the diameter. Also, if I had an aerial view of the mountain, if I was in a helicopter, I would have to have some sort of scalar reference. I would have to hold my elevation. I would have to ride in a helicopter, which I don't want to do. Sonar would also have issues, because what if I didn't know what sort of material was inside the mountain? So maybe the mountain is dirt until this point, and then there's a huge nugget of rock in the center obscuring my sonar. Okay, so instead, what I would do is I would pick a point and I would measure this distance to where I want the beginning of my tunnel to start. Okay, so measure that distance. That gave me 583 feet. And then I would measure where I wanted my tunnel to end to my starting point, and that would give me 750 feet. And then I'm going to measure the angle between the two, okay, and that gave me 84 degrees. Okay, so what I did is I drew a little reference triangle over here and gave it the proper labeling. So I don't really care what beta is, I don't care what alpha is, I want to find A. Alright, so I want to find A, then I'm going to use this formula up here. So I have that A squared equals B squared plus C squared minus 2 BC times cosine of alpha. I'm going to go ahead and enter in my numbers. So I have that a squared equals 58.3 squared plus 750 squared minus 2 times 583 times 750 times cosine of 84 degrees. Alright, now when you solve this and you get down to the bottom, right, you're going to get an answer. It's going to be a very large number. Don't forget to take the square root. Alright, so take a minute, work this out on your own, pause the video, get your answer. Okay, so I'm not going to be working this out right here. I feel like you guys can add, subtract, multiply pretty well. So I get that A is about 900 feet, which is a really good estimate. That gives me an idea of how much material I'm going to bore out of here. It also gives me an idea of the pavement I'm going to need to lay down, etc. So A, got 900 feet. Okay, they also do the same thing when they're measuring houses or land. If a house is in a way and they can't get a proper measurement of the acreage a land mass has, they'll also use this a lot. Or if you see them trying to measure a field that's obscured by a lot of bushes or a swamp or something, they also use this. It's pretty cool. So let's do another example. So I am asked to find the interior angles of the triangle with side lengths A equals 12, B equals 7, and C equals 10. Alright, so here's a tip. Start with the largest side first. Okay? Now what the largest side is going to give you is it's going to give you the largest angle. Okay, so largest side equals largest angle. Okay, so let's go ahead and let's start with A. And then we will find alpha. Alright, so we have A squared equals B squared plus C squared minus 2AC cosine alpha. This time I am going to go through all the algebraic steps of this, so you can fast forward the video like 2 minutes if you want to, or go ahead and pause it and do the algebra yourself and then do a quick check. Okay, so it's going to be 12 squared equals 7 squared plus 10 squared minus 2 times 7 times 10 cosine of alpha. So 12 squared is 144, 7 squared is 49, plus 100, minus 7 times 10 is 70, times 2 gives me 140, cosine of alpha. Okay, I add these numbers together, I'm going to get 149 minus 140 cosine of alpha. Now some of you might feel the need to subtract these numbers right now, but don't. That is bad algebra. Okay, so leave it this way and just go ahead and we're going to start solving for cosine now. Okay, so it's going to be minus 5 equals negative 140 cosine alpha. Divide both sides by negative 140. And that's going to give me 1/28 equals cosine alpha. And remember, when we're solving for an inverse, or solving for an angle, we're going to take the inverse. Okay, so that means we're going to get cosine inverse of 1/28. It's going to give me my alpha. Okay, and that equals, I'm going to round it to a whole number, that equals 88 degrees. Okay, so let's go ahead and label that. That means that's 88 degrees. Alright, now if you want to be a die-hard fan of cosine, you can absolutely solve beta and gamma using law of cosines as well. I'm going to use law of sines. The reason is that I have a lot less algebra to do and a lot less numbers to keep track of. Okay, so I'm going to go ahead and let's solve for, let's go ahead and solve for beta. So I'm going to have sine 88 degrees over 12 equals sine of beta over 7. Okay, so that means that I multiply both sides by 7. And then if I solve this side, I get 0.58 equals sine of beta. And then I get that beta equals, I'm going to round this up as well, it's going to equal 35 degrees. So let's label that, that's 35 degrees. Now, again, if I'm a die-hard fan of trig, I could use law of cosines or law of sines to solve for gamma, or I can use a neat little trick that we learned at the beginning of the term, which is I could do 180 minus 35 degrees minus 88 degrees, which is going to give me 57 degrees, which is my gamma value. So that's 57 degrees. Okay, so always start by solving for the largest side first, using law of cosines, and then you can solve for either of the two remaining angles by using law of sines, and then using this little trick down here. Okay, so we have step 1, step 2, and step 3. Okay, so first starts out pretty gross. You could probably do this in your calculator, and then it gets not too bad. Okay, not too bad at all. Alright, next we're going to change gears a little bit. We're going to move on to area formulas. Okay, so let's just write down our standard area formula. So we know that the area of a triangle is 1/2 base times height. Okay, so let's say I don't know the height. So let's take sine of alpha. Sine of alpha. So I know that's going to equal h over c. Okay, now if I solve for h, then that's going to give me h equals c times sine alpha. So that's my height. And I know that my base is b. Okay, so then my area is going to equal 1/2 my base, which is b, times my height, which is c sine alpha. Okay, not too bad. We can also rewrite this in other forms. So say I had decided to label like this is beta, this is alpha, and that is gamma. Right? Then I could have written this as a c sine of beta, or 1/2 a b sine of gamma. So it really depends on what information you're given and how you label your triangle. All three of these formulas work the same way. We're just calling our sides and our angles by different names. Alright, so this is also very useful in surveying. If they can't get across a lot to measure the height, if there's, again, a house or a pond in the way or something that they can't physically move across, then they can just find the lengths of these sides and then determine that angle right there and find the area of a lot. Okay, very simple, not a lot of hard work. You don't have to try to build a bridge over something unstable like a swamp, for example. Not all lots are perfectly square. We'll get to that in just a second as well. So let's do an example. Let's say that we did measure a lot. Let's say that we measured a lot and it's 34 feet by 42 feet and it has an interior angle of 55 degrees. Okay, so I'm not even going to label these because I know I have a side angle side. So I know that A is going to equal 1/2 34 times 42 times sine of 55 degrees. Okay, let's go ahead and put that in our calculator and see what we get. Okay, so we're going to have 1/2 times 34 times 42 times sine of 55. Okay, so then I get that the area of this lot is 584 point, I'm going to round this up, 88 feet squared. Don't forget to put your units. Okay, if you were to just hand this to a contractor, they wouldn't know if you're talking feet squared, acres squared, miles squared. It's important to have this down here. Okay. That's area. And then let's move on to one more area formula. This is called Heron's formula. Okay, so it's K, so we denote area by K in this case. K equals the square root of S times S minus A times S minus B times S minus C, where S equals 1/2 A plus B plus C. Okay, this is called the I think it's called the semi-perimeter. Okay, this is also useful if you didn't have a device that measured angles accurately. So say that you're in ancient Egypt and you had to find the total area of land, right? But you didn't have a protractor because you're in ancient Egypt, then that is when you would be using this formula. Alright, so let's do an example. Let's say we have A equals 8, B equals 10, and C equals 13 on a triangle. Let's go ahead and let's find S first. So our S would be 1/2 times 8 plus 10 plus 13, which is 1/2. Let's see, that's 18 plus 13. That's going to give us 31. Okay. And that's going to give us 15.5. Right, now that we know our S, we can go ahead and start plugging it in. So we have that K equals the square root of 15.5 times 15.5 minus 8 times 15.5 minus 10 times 15.5 minus 13. I could just plug it in my calculator like this. I'm going to go ahead and do some of this work by hand. So that's going to be 15.5 times, and this is going to give me 7.5 times 5.5 times 2.5. Go ahead and draw it like that. Okay, now I'm going to plug it in my calculator. We're going to do 15.5 times 7.5 times 5.5 times 2.5. Take the square root of that. And we're going to get 40.77. Okay, so I'm going to get that K is about 40.77. Okay, so that is good. Now let me give you some examples of why we would use Heron's formula or our other area formula to find the area of a field. So as you know, or I don't know, as you might not know, as you might conjecture, I guess, is that not all the fields in Egypt or anywhere else in the world are triangular. However, it's very simple for me to take any shape, such as this one, kind of looks like a little sideways Pac-Man, and what I can do is that I can cut up this area into triangles. And then I can measure the area of each individual triangle. And then I can find the area of a field and then give due tax. Now, let's say a very unfortunate event happens and I put my field right next to the Nile and it washes away a good chunk of my field. Okay. Well, notice that I can still construct some pretty good triangles to give you a good estimation of my new field area, as well as my area that was lost in the water. Alright, so that might give me a good reimbursement if I'm in the middle of the year and something a flood happens near me, then I can get reimbursement for my taxes from what has washed away. Alright, we can also we'll see in a couple examples of how we can use law of cosines. If we have several measurements but are missing a side length here. So say, for example, that I have all of these measurements, but I'm missing this measurement because somebody has, I don't know, what's something that would obstruct a field in Egypt? Let's say that there's a swarm of locusts here, and nobody wants to go out and, and measure this distance here. Okay, well then I can say, don't worry about it, we got all of these measurements, we're genius mathematicians, we can just use law of cosines to find this one. Okay, we'll be getting into that a little bit later as well, mostly in class activity. Okay, so that does it for section 8.2. And we are on our way. We're almost at the end of the term. Oh my goodness.